Everyone. Let's welcome back to our YouTube video tutorial to the course deep learning. Today let's try to discuss about the recurrent neural networks, which is one of the deep learning algorithms. So before that one, actually, the slide will be adopted from these sources. So just I wanted to say thank you for sharing the slides. So let's start from the introduction part. That will be discuss about the what is recurrent neural network. So in the previous video, I just tried to mention about the artificial neural networks, multi-layer perceptrons, and about convolutional neural networks. So this type of data just like try to take one data sample as an input, and the outputs just like output one results as a feed for our neural networks. So in this case, as the only just try to pass the data layer by layers and obtain one output for one input like that one, it will be done. So in multi-layer perceptron or in convolutional neural network, just like for instance, when you give one data, the output will be also displayed as one. So just we can give this image and then we can get one output like this one. So just like this is the way of like, and this is for instance a sentence, and the output based on the answer it will be give some information. So the difference between CNN and RNN is that's why. So in recurrent neural networks, which is like try to even accept like even more than one data, and the output also it can be the input is more than one and the output also is just like more than one output. It can be possible in recurrent neural networks, and the other one is RNN is that can be used to for a type of time series data, so we call it sequential data. So let's see in detail about this one. So this recurrent neural network or RNN, which is a type of neural network where the output from the previous step is fed as an input into the current step. That is why just RNN will be a sequential or time series one. So just the output from the one node will be input into as an input into the next layers will be that one. So in traditional neural network, or like for instance in traditional artificial neural network or in MLP, all the inputs and outputs are independent of each other, which means like for instance if one data just inputs, so there is one layer here, another layer will be here. So this one will be the one data is independent over here, and this one will be independent just in traditional artificial neural network on the other layers. But when it comes to in the recurrent neural networks, like it's required to predict actually this one, the node information from this node will be just transferred or passed into the next one. So still actually the next node can have access on information from the previous ones. So that's why actually this will be different from that one. So the previous words are needed, or the previous information will be important for the next nodes for in terms of recurrent neural networks. Just like the main and most important feature of RNN is the hidden status. This is the hidden state that try to remember some information about the sequence. So that is why a recurrent neural network is just have a memory. This memory can try to store information about the data, and that data or information will be help us later to decide the generalization or like the classification or detection and like this type. So this RNN have a memory that retain all the information about what has been calculated, what has been done before, and what have that just that image or information or data should have that will be stored. So just like in the connection of different hidden layers, they use the same parameter for each input so they perform the same tasks or on inputs or hidden layers to produce the outputs. So this is just try to reduce the complexity of the parameters unlike other neural networks. So in the other neural network, actually they didn't use like the same parameter and like that one, and that's just increase the complexity. But when it comes to the recurrent neural networks that try to assign the same parameter for each inputs, and then they try to perform the same task, and that will be help us to reduce the complexity. This is, for instance, the difference between feed-forward neural networks and the recurrent neural network. In feed-forward neural network, for instance, this is the input or data, and this is the hidden layer. So input or data will be just feeding into the hidden layers, and then information is just like passing to the next one. So the next hidden layer cannot access information from the previous one. But when it comes to in the recurrent neural network, this is just the data input into the hidden layers, but the information is still just reused again from the next hidden layer. So this is just it's return back and reuse the information in the next hidden layer. So that is just the main or the basic difference from this one, because in recurrent neural networks that uses a memory, that memory can retain all information, store all the information, and it can be used for in the next decision or in the next process. So this is just like show that how the just like I already mentioned that RNN is that is important for a type of sequential data or time series data. That means we will be just have a time series, like for instance within this second, within different second or with different time series, the data nature will be different. For instance, let's say take temperature data. When you take temperature data, the data will be just different within different time frames. So in the morning it will be different, and then maybe after some minutes it will be different, and in the afternoon it will be different, even like after some minutes it will be different. So throughout the 24 hours we can get that different data natures. So that is just a screenshot or time series data. That means time have an impact on the data sets. So when you say that screenshot, or I mean just single images, which is like for instance in convolutional neural network, this is an image. This image will be given for CNN, and CNN model just try to just categorize by using like high level information. Then object class, object pose, and the DPs like help us to detect or identify the image, like doing like this one. So only we can give just one image, and then the model just try to object either classify this image or also just like posing, identify the pose of the image, or just detecting the image. So just it's a single image. When it comes to in the RNN, or when you say that screenshot data, the data depends on the time. Let's see for instance this video. So in this video, you see that the time have an impact on the information. For instance, at time t1, at time t minus 1, this video it showed that, or this image it showed that actually the person will be just moving from this one to this sides, and there is a gap between these two guys and this one. Maybe the image will not be clear. So in this case, at time t actually now the position will be changed, and the man is like almost cover the other two, and here is already start to pass. So the model can try to use all these information step by step, and that helps us to clearly understand about the video. If we take only this image, just the information is different. When you take this image only, the information is different. When you take this image only, the information is different. So instead of that one, in sequential data, all these images or videos will be given for the model, and the model can try to extract all information from different screens of the data, and that is help us to understand more about the data nature. This is another example. For instance, it's a sentence type of data. UT Dallas is Rising Public Research University in the heart of DFW. So this is just like, for instance, different screens of. So from this one, if we take only this one, maybe the meaning is different. If only take Dallas, the meaning is different. Instead of that one, just the sentence will be just using the whole with different. So the screens also different. So from this one, from left side, then next this one, next this one, next this one, this one. So with different time when you speak actually, the screens will be different. So from the beginning to the end, that gives a full information about these sentences. So that is why sequential data in RNN will be taken step by step, each data sequentially, and that gives full information for the model, and that helps to just to make it a good generalization or a good output. let's see, for instance, when you say that sequential data, this is actually just the layer is like artificial neural network or CNN. Actually, the structure is always have input layer, hidden layer, and output layer. So almost when you talk about artificial neural network or deep learning, the layer always just like the structure is common. Like there is input layer here, and the hidden layer, and then output layer. So this is input layer, this one is hidden layer, and this one is output layer. So 3 layers, but actually the connection will be different. So when we interconnect this input, hidden layer, and output layer, actually there are different way of connection. For instance, in one-to-one layers, this one it shows that let's say one-to-one layer. In one-to-one, just which is an example of feed-forward neural network or traditional neural network. So in this case, the connection is only one-to-one. That means just there is one input and then there is hidden layer, and we can get just like one output. That's just a way of one-to-one. So input one, hidden layer, and output will be just like this type of it. We call it feed-forward neural networks. So it's in this case is non-time series data or non-time series problem, such as image classification and for object detection. So we can give just a single image. Let's say this one is a person image given for hidden layer, and the output will be just like try to classify whether this one is human or animal, like that one. So that type is, we call it one-to-one type of the model. The other one is one-to-many. One-to-many, so one data input and many data outputs in order. So the input may be just one, and there are hidden layers, sequential here, and the output maybe is many. For instance, image captioning. Input an image to generate a sentence. So let's say, for instance, we have one image is given die. So let's give one image for the model, and the model just try to just caption what the image shows. Like for instance, we can input image, and then let's say the text will be the man is playing football. So from one image, the text will be more than just like around 4 words like this one. So the image is one, but the sentence will be more than a sequence of 4 or 5 words. That type is, we call it one-to-many. So that is the structure. So here, let's say for instance, this one maybe just one people, sorry, and then this is just we call it the like this one. So this sentence will be a sequence of 2 or more sentences. That just like that's the sample. So the image is one, but the sentence will be more than one, or a sequence of more than one or 4, 2 or 3 words. That is just, we call it one-to-many types. That's just an example. The other one is just many-to-one. In this case, the input is many, but the output will be just one. So multiple data inputs and a single data output. So sentence sentiment classification. Sentence sentiment, for instance, for the application of sentence sentiment classification. So which means input a sentence in order, and the output is the probability of happiness. For instance, we can give a sequence of video frames or just a sentence. From that one, we can just like action classes, or let's say, for instance, just like or a baby cry more. This is a sentence that input into the RNN. So from this one, the model just can try to predict whether the baby is happy or not happy. So from this one, actually the sentence will be more than one, a sequence of one words, and the output may be just like whether the baby is happy or not. It try to say that the output will be not happy or just happy. So the sentence will be a sequence of more words, but the output is just happy or not happy. So just one word. Because of that one, we can say that this will be many-to-one. So this one is maybe not happy. Let's say this. The sentence is given and the output is maybe not happy. like this one. So that's a way. And the other one, other example, actually, as already mentioned here, is like screens of video frames. We can give like the previous one, maybe screens of different video frames. And then finally, we can say that from the video, we can say that some sentence, whether the man is happy or not, just like this is also an example of many to one examples. There is also many to many, which is like we call it unseen queries or sequential to sequential. So multiple data inputs and multiple data outputs. So for instance, language translation is an example of many to many because we can give many words from English to Chinese. So if like the word is for in English, maybe in Chinese also, around the output is also for words. So language translation input the entire sentence to model before starting to generate just translated sentences. So we can give like, for instance, some words in the output also more than that one. For instance, this one actually is image captioning from the previous examples. From this image, actually, we just like try to generate different captions here. A cat sitting on the suitcase on the floors, two people working on the bench with. So from by just checking these images, the model automatically generate like this type of image caption, an example. The other module will be multiple data inputs and multiple data outputs also, which is synchronous or simultaneous. So weather prediction, input the information to the model in every time steps, and the output is predict weather conditions. So this is also an example of like synchronous or simultaneous way of the models. Let's see, for instance, this is an example of video frame labeling. This is a full video. So the video, this one is actually a video. So the video will be just like cut into different frames. The first frame, this one, second frame, this one, second, then. So all these frames just have give different information for the model. So the first image classifier, it showed that standing here, the man is standing. In this case is falling. In this case is falling. In this case is back flipping, falling, and sitting. That means within different this one frames, actually the information will be different. So the model, by combining these all frames, it gives just like have full information about that one, and based on these informations, the model will try to decide the output. That is the way of sequential data labeling. It means this one. So finally, actually, all this one, maybe just like in the first hidden layer, this one is given, second hidden layer, the next one, second hidden layer, the next one, and then finally the output layer is just like at the end will be the output layer. That means by combining all this information, the output layer have all this information sequential. So this is just the way of recurrent neural network. Means actually this is like the information from this one input into the next one, input into the next one, like this. So the just like the information is stored here and passed to this one. So still the information from here is important for this one, and the next one also just access all information from this one. That's just we call it recurrent. Store and process the temporal information from the previous ones. So just let's try to see that how the recurrent neural network works. So suppose there is a deeper network with one input layer and three hidden layers and one output layers like this one, for instance, as a sample. So then like other neural networks or other like traditional neural networks, each hidden layer will have its own self-weights and biases. So weight and bias will be assigned also in the recurrent neural network. So let's say, for instance, hidden layer 1 will be weight and bias of just like weight 1 and bias 1. And then the second one, weight 2 and bias 2, second hidden layer. And third one, weight 3 and bias 3 for hidden layer. So for each layers hidden, the weight and bias will be assigned. So this means that each of these layers are independent of each other and they do not memorize the previous ones, just like in traditional neural networks. It will be work like this. When you come to in the neural network, recurrent neural networks, like this RNN convert the independent activations into the dependent activations. by providing the same weight and bias to all the layers. So in that case, in the traditional neural network, like the weight and bias is assigned like this one separately for each layers, but in the recurrent neural network, this weight and biases and activations will be just like assigned the same weight and bias to all the layers, and this one can help us to reduce the complexity of increasing parameters, and also that helps to memorize each previous outputs by giving each output as an input to the next hidden layer will be the most important thing. Hence, then let's say for instance we have just like 3 layers from input layer, output layer, and just like the input, hidden, and output layer. So it's these 3 layers can be joined together so that the weight and bias of all hidden layers are the same into a single recurrent layer. So will be just like like this. So in the recurrent neural networks, there is an input X and given for the recurrent neural networks, and also it can be reused information for the next hidden layers, and then we have just the output Y. So RNN have an internal state that is update sequences proceed. Just it can be update information from this one. So the structure will be recurrent neural network that different from the traditional neural network will be because in recurrent neural network, each layer of the network will be interconnected, and also it will be reuses information from the previous layers. That is just the basic difference. So for instance, this one, you see that this is the input time at time frame t, because just we can say that it's a sequential or time series data. So the data will be just different within different time frames, and input into the hidden vector of the time or the layer, which this one. So then the information also just like comes into here and hidden enter into the other layers, and then there is also the hidden vector frame of the next layer like this one. So the only difference between the RNN and the feed-forward neural network or traditional neural network is in recurrent neural network, feed the information of the previous time steps to it is the next step. That is just the only information. So this one just like we represent like this one. This will be just like time more explained like this one. So at time t minus 1, the hidden layer h time. So this one we call it the previous layer, and this is the current layer, and this will be the next layer. So at time t minus 1, at time t, and at time t plus 1, just like with different layers will be connected at different times, it will be represented. So that is just the most important characteristics of recurrent neural networks. Here like the same, like from the, for instance, this is a sentence. I am from China, so I speak Chinese. So all this information is input into, for instance, for the recurrent neural network. So we can give like each word as just like a time frame. So this one time frame with different time frame for this one, for instance, and this one will be represented separately here. So the equation will be just like represent actually. This one is the hidden layer and the output layer. Just we can try to see that one in the previous one. So the structure will be represented like this one. For instance, this is the picture that showed that how different hidden layers will be connected. For instance, this is the previous layer, the current layer, and the output layer. So with different time frames, this one will be given like according to this one. And this is actually the hidden layer that represent, for instance, this is the activation function. There is weight and input here, and the hidden layer like the previous hidden layers, and the bias is also given. And this is the output layers that will be represented from this one. So recurrent neural networks, just like there are different equations for calculating the current status. For instance, I think this one is in the quality of the images a little bit, yeah, just like in the recurrent neural networks, it will be shown that here ht minus 1, ht, and ht plus 1, this is just like the hidden layers with the previous one. So ht, current state, we call it like, for instance, ht is a current state, and then there is a function here HT minus 1 will be just like the previous state. So it will be take from the previous hidden layers, and then XT just like the input states. So the current state will be the function of the previous plus the input, or XT. That's just the information. So here, this is that HT you see here. XT is input to here, and also there is information from the previous one. HT minus 1 is also come from this one. XT is called like this one. So this HT is a combination of HT plus 1, I mean minus 1, and the XT. That's why this equation will be represented like this one. So formula for applying the activation function, for instance, HT will be tan H of WH, HT1, and then this is actually just apply the weights also, weight at recurrent neurons like this one, and the XH is weight at the input neurons like this one. So just like the weights also applied on the input neuron and the recurrent neurons, then we can add activation function for nonlinearity also, like the previous one. Then finally, we can calculate the output layers. Output layer will be just like weight times the current state. So HT is a current state, like also here. So from this figure, just like from like this one, so YT, just the output layers, or the final one will be just like the combination of this one, activation function tan H is like the given, as already mentioned, like this one. So YT is just like the outputs, and then the weight and the output vectors will be represented. So there are different layers actually on this one. Maybe let's see in detail about this. So the equation, the new state, always we can just like process new state is some function, and this is old state, and input vectors at some time step will be the function of this one. So the new state always the function, just like that, consider that function, and then consider the previous information plus the new information. So in addition with new information in the recurrent neural network, it will be uses for the previous information from the previous hidden layers. That's just the most important thing. So YT is the outputs. We say that the output, so we can process sequence of vector X by applying recurrent formula at every time step. So YT, or the output, will be another function with parameter with weight, and then there is new state. So there is new state with the next step, so we need to use that one. HT will be the next state, so the function will be like this. So you see that this is the structure, how like the recurrent neural network it will be looks like that one. So this is the data set with in different time frames. This is with different layer of a recurrent neural network, first layer, second layer, like third layer and fourth layer, like, and the different output from each layers. But the information from the first layer will be passed into the second one, and the second one, and the second one. So the output, the final output will be just like by combining all these informations. This, the final output will be the combination of like this one. That's just recurrent neural network will be different from the traditional full forward neural networks. So let's try to see about how we can train through the recurrent neural networks. In recurrent neural network, is a single time step of the input is provided into the network, just like the data. Then try to calculate its current state using a set of current input and the previous state. So just like in order to calculate the current status, using a set of a current input, that is XT, plus the previous state, which is like the from the previous one. So still the current state is, or current data is this one, also which will be considered the input from the previous state, that's just this one. So the current HT is become HT minus 1 for the next time steps. For the next step time step, it will be become HT minus 1 because it can be considered as a previous state. So once can go as many time steps according to the problem, and join the information from the all the previous states will be just do like this one. So the procedure I think will be like this one, see. So this is the previous state, and this is the function, the current one, the input is here, and then the next step it will be come like this. You see, so there are different inputs, so the combination will be this one. So the most important parameters in the recurrent neural network, just the weight and bias will be assigned for the whole neural network, just like the same type of weight and bias. But in traditional feed-forward network, this weight will be different in each layers. For instance, different in this one, different in this one, different in this one, and different in this one. But in recurrent neural network, the same weight and bias is assigned throughout the whole type of the layers. So that is because of that one, it will be reduce the complexity of the problem. So there is function, it accepts new input here, new input here, new input here. This is layer, and finally the output will be determined using this structure. So this is also in sequence to sequence modeling, as I already mentioned. The first one, there is different ways, many to one and one to many type of connection. That means actually the input is many, but the output is one maybe, and the other one is maybe the input is one and the output will be many structure. So this is just like it showed that this is, for instance, there is many inputs, x1, x2, x3, and but finally the output will be one, and the weight is like this one. But in this case, actually, the input will be one, but the output will be just like many. So produce output sequence from a single input vectors, that's just a structure. So this is, it depends on our data nature. Sometimes maybe we can give some number of inputs and then the output only maybe one, or on the reverse. Sometimes maybe just like the input is one and the output will be more. Like for instance, image captioning is, we call it like one to many. We can give one image, but the captioning that just says that maybe like more than 4 or 5 words of a sentence that tell about the image. That's just an example. So there is a problem in RNN, recurrent neural network, but have some problems. So also this basic recurrent neural network is fairly effective, but still it can suffer from significant problems. So one of the main problem for this recurrent neural network is the vanishing gradient problems. So this occurs when the gradient become very small and tend toward the zero. So because of that one, actually, we try to find that the best or the optimal solutions. And also exploding gradient is in the other problems. This occurs when the gradient become too large due to propagation. So when you say that actually this is like the gradient become very small like this one, it's just like when like the iterators actually it will be goes into the minimization of the error. So in that way it's like tends to 0. So because of that one, the performance of the model is not good when comparing to that one. So so in vanilla or traditional recurrent neural networks, for instance, it's difficult to maintain information for long time. The other problem will be limitation, long-term dependency problem. So it cannot be capture information for long times. Thus, to solve these problems, actually, a solution for these problems, it will be proposed like long-term memory or LSTM, and GRU is a type of recurrent neural network that's just improved from the recurrent neural network, and that helps us to solve the problem of vanishing gradient problem, and also that's like the other problems, and also this time memory, or just like the problem of this long-term dependency problem is also solved by using long short-term memory network and gradient recurrent neural network or GRU. So let's try to see about what is LSTM and GRU. So when you start from long short-term memory or LSTM, long short-term memory, as the name indicates, actually this LSTM have just like a memory that start to or that helps to store information for long times. So for solving long-term dependency problems, this LSTM will be one of the best algorithms. So this type of long short-term memory have a memory that have just store information for a long time. So this is, for instance, the structure will be different. This is a traditional RNN or vanilla RNN, and this is the LSTM structure. So as shown in this diagram, actually, in LSTM, the structure will be more complex than this vanilla RNA. So because of this structure, LSTM will be have a long-term dependency, just that store information for a long time, and that just helps to also improve their performance. So this LSTM is a type of recurrent neural network that's designed to address the vanishing gradient problem and also like long-term memory or store problems. So in general, there are three key parts or features of this LSTM. There are memory cells, gates, and long-term dependence are like the most important features, which means have memory cells, this thing that helps to retain information over time. The other one, LSTM have different gates. These gates can just help us to monitor informations. So for instance, have input gate, forget gate, and output gates. So these gates can help us to regulate informations into and out of the memory cells. The other features will be long-term dependency, which means that LSTM can capture long-term dependencies in sequential data. So just like that helps us to store information for a long time. And this will be that helps us to make effective for in long-term dependence, or that just needs some memorization, like in speech recognition or machine translation will be mostly effective like this one. So the most important parameter or features in LSTM is have three different gates: input gate, output gate, and forget gate. These three gates will be just like that, can be help us to regulate the information that can be input into the model and also output from the model. So input gate that try to decide the information in the cell that needs to be added onto the cell state. So it will be just help us to regulate or monitor what type of information will be input into the models or added into the cell states. And the output gate decides which part of information in the cell should be just like or will be output as the current status. So it will be help us to decide the information that will be just output from the current states. And forget gate that helps us to decide information should be dropped from the past cell states to reset the partial memory. So when you say that forget gate, actually in order to free up the memory, because just LSTM uses a memory state to store information, so sometimes maybe the memory will be full. So in order to just solve that problems, the forget gate can just like by controlling or regulating the information try to just replace or drop unnecessary or just some irrelevant informations. So this way, just LSTM can try to remove and adding information to the cell states rather than fully overwriting. So in LSTM, no need of fully overwriting, rather than just like by controlling or by using different gates, try to add or remove information into the cell states. So the other one, just like because this type of recurrent neural networks, this type of algorithm try to just like connect prior information into the current tasks. So the previous information will be important into the current tasks. This is a structure of a basic structure of LSTM and some symbols to use in the LSTM. For instance, this one, it showed that x t minus 1, which is a time frame at time minus t time t minus 1, and this is, we call it the previous state, and this is the current state, and this is the next state. So always when you talk about recurrent neural networks have just three different states. The previous state have information from the previous one. So right now we just, let's say, in the current state, so we are here, and then they have also the next step, maybe just the next procedure is also waiting. So in order to draw that one, for instance, this the shape actually show that the neural network layers like this one. Pointwise operations, like for instance this one, like calculation or multiplication, will be defined by using this color. Vector transfer from one to the other one. Concatenation, this symbol, and this one symbol should get copied from these symbols, just a symbol. So this is just like the information that showed that how like different gates used in the LSTM. So the This one is current state, and this is in next time with different time steps. And also this is like actually the cell state with like this one is the previous one, the current one, HT, and HT plus one, like this. So from this one, two key ideas of LSTM, like for instance the gating or pointwise multiplication to modulate information flows, like this one. For instance, here in the previous status, CT or current state will be just like the previous current state is given. So there is also this pointwise multiplications to modulate information flow, like this one. So this one will be given. There is here that determined for the different multiwise gates. So this is just like, for instance, from the previous one, it's like passed into this one, and we can get the current state actually this. So let's start from different gates. So the first one is forget gate. So this F gate is or forgetting gate. We can use like a previous state C, previous output H, and current input X. So current input X and the previous output is HT minus 1, like this one. And the previous state is here CT minus C of T over time T minus 1. So just to determine how much to suppress a previous states. So forget gate will be like this one. It uses the current data plus the previous hidden states. This is the activation function, and forget just like is like this one. So if it is this one, the activation function, this one, the equation will be calculated this one. Then weight of the function, which is the weight here, and then HT minus 1. And then also there is a concatenation with HT here because he's already is combined, plus there is a bias here. So the equation will be determined by using this one, which is a forget gate that determine how much like the information will be overwrite. The second one is input gate. This determine which value of C is to update. So for this one actually still uses the previous hidden status and also current information or data. So input state, it will be just like there is the same like here, plus there is a weight and the previous one, then the current one, this one, and plus the bias one. So just this is the one that will be just like try to do the input state or the information will be calculated. Plus the current separate layer, that's the added some new status here. A new state is added here. This state will be tan H off. There is a weight of C, and then there is also the hidden state with the previous one. This is the current put plus the bias on the C, or this will be just added. The other one is forget gate, that just like try to forget information. I mean the forget gate is actually it's already seen like this one. There is also update to see those. The update gate actually just like try to update information from this one. So it will be calculated. This one is like a new state. We call it actually a new state. So this new state will be a combination of this one plus this one by using different pointwise modulation of C. So this one is will be input FT, and there is also CT minus 1. This one times this one. This means, and plus then IT times CT here. So this one, a new state will be a combination of the multiplication of this one plus the multiplication of this one. So this one, a new state will be just like calculated like this one. So this one is forget previous information. This one is about forget previous information. And this one is about input new informations. So a combination of this one, just like try to update the information by forgetting a previous information, and by adding new information, it will have a new cell status in the LSTM memory. So the output gate will be just the output will be like this one. Output gate OT here. So there is also the previous state and the input gate like this one. And then just finally the output gate is coming this one by combining this one OT times here actually the output from the this one. This is times actually that's come from this one, tonnage of CT, which is like comes from this one. So the output will be just like modulate, which is like it's passed from the C or the update gates. So just like the output gate will be just like that uses a new status or the, so by using like this one, it will be determine the information from the previous one. So this LSTM, because of these memory tools, that can be used to just like for a data size, which is have huge data sizes, which have a memory that remember about this one, and the information will be stored for a long time. So this is like because of LSTM is type of time series type of module. So the data set should be time series or sequential data set. This is an example. For instance, data, digital signal waveform data, network traffic data, and the equipment state parameters. And this one is input into the LSTM here, or a recurrent neural networks here. And finally, for instance, in optical communication, that helps to network fault management, equipment failure prediction, network traffic forecasting, digital signal pre-distortion. Like this type of application, it will be important to apply for different purposes, not only in optical communication. So in different disciplines, this LSTM or an algorithm that try to solve different problems if the data set is especially type of time series or sequential data sets. The other algorithm or type of RNN will be get recurrent units. So this is actually almost similar with LSTM, but a little upgrade or improve of the LSTM algorithm. So GRU is a variation of LSTM that also adopts the gated design. So the only difference actually in LSTM, the total number of gates will be 3, but the GRU will be try to improve a little and then makes like just only two gates. So GRU uses an update gate that substitutes the input and forget gate. So input and forget gate will be combined and just say that update gate is all date. So by combining the cell state CT and headed state HT in LSTM as single state, but so in this case it try to combine that one. So actually the performance will be a little bit like almost similar, but just like GRU is an update version of LSTM. So especially in a small amount of data, maybe GRU is like achieve the better performance, but still actually the performance will be just like almost similar. So this is a structure that shows how like the GRU graph it looks like that. So ZDT is an update gate. This update gate actually just like the equation will be shown like this one is represented using equation like the previous one actually from this one. So the update gate that combines the role of the input and forget gates. So it try to help decide how much of the information to keep and how much will be added into the cell state. The other gate will be reset gates. So this reset gate determine how much old information is forget or needed in the new hidden status. So reset gate also just like the equation is shown like here. So from this one actually there is a reset gate here, update gate here, it will be just shown here. And also there is new state actually that represent on this one is replace selected old information. Replace selected old information with new information in the new state. So the new state will be just the information is already forget, and new information is active. So that updated one we'll call it a new status. So just the only different from the LSTM will be just the internal structure is a little, the complexity will be reduced on the GRU. That means actually the time complexity will be reduced in GRU. So the basic difference maybe because of the internal structure, GRU is simpler than LSTM. So it takes like actually the training time will be reduced in the GRU. And LSTM maybe actually because of have just long memories that will be just like better on the huge amount of data sets, but just mostly actually based on the complexity, GRU is more better than LSTM. But in terms of performance, sometimes maybe LSTM will be better, or sometimes GRU is also depends, but almost the performance will be just like approachable. So this is a structure that shows that about the gate recurrent neural network. You see that here there is a reset gate, and also there is the update gate as ZDT. So this one actually just like there is a current data from here, wait, and this one the previous hidden state. So from this one actually a structure. This one is coming through this way, and also this one is also goes this one. So wait ht minus 1 and xt will be like this one. Reset gate also just like this one. So still the previous one, and the xt also here. Then this one ht will be as a combination of tan h, and then actually this is just like that. Try to combine all the information from this one. So this ht, this one will be just like, for instance, it will be given from here tan h, and there is a weight here plus to this one there is rt times ht minus 1, because ht minus 1 times rt here, you see like this one, and there is also a current state xt, because actually this one is still is coming into and enter into this one. That's just like, that's why the reason we call it as time. And this ht will be just like 1 minus zdt, because here you see that 1 minus zdt, and there is also multiplication here, and plus then ht minus 1, just like this one, for instance, plus also zdt and ht, it will be just like this one, times ht. This is a multiplication, so this is a plus will be defined like this one. So the structure will be that one, but when you compare into the LSTM1, the internal structure will be simpler than the LSTM. So because of that, just like maybe GRE is more better than the LSTM in some ways. So in this way, actually, just like there is also sequence learning, like the combination is like this, and also overfitting and underfitting problem is the same also happens. So the way like solving this type of problem will be the same like in CNN, already shown in CNN, I mean in the CNN, also in the artificial neural network. So similar ways like dropout, regularization, and the other technique is the same. So just follow that procedures. So now let's try to see about how we can implement RNN models using the Python or using the Keras. So this is just Keras actually just like to implement like this one. We can say that using, for instance, RNN model is just like we can use RNN keywords, and for LSTM we can use LSTM, and for GRE we can just like that Keras layers dot GRE. So this one, so just we can define here the number of the neurons here, activation function here, and then just like this is the keywords. Then we can add different parameter for this one. That activation functions we can give like this one, recurrent activation or activation for the gates will be defined. Return sequences, for instance, true is like to obtain the output on each time step. Return sequence is if we say that, for instance, true, which means the output, or we can obtain the outputs with every time steps. If we say that false, to obtain the last output, only the last output will be displayed. That's just the implementation. So let's see how we can implement. For instance, this is a sample code using LSTM and GRE for FPGA sensor peak wavelength detection technique. So this is a sample real projects how we can use LSTM and GRE for a sensor data analysis. So this is a library that uses for implementing this one. For instance, this is import panda as a PD, which is define the data structures. PD is the data frame, and also import matplot as a PLT. So this is just for visualization, plotting. There is pre-processing for data pre-processing, standard scaler for normalizing our data or scaling our data. So we need to just normalize or changing the data according to the format that the computer or the machine will be understand. NumPy as NP, this is for matrix multiplication or for array. From keras.modules import a screenshot. This is just for because the model is a screenshot, so always we need to import this screenshot. So this recurrent neural network LSTM GRE is a screenshot or time series model. So that's just the purpose. And we need to import dense LSTM and GRE for implementing the LSTM algorithm. So we don't need to just write every LSTM codes from scratch. And instead of that, we need to import these libraries, and simply we can call it LSTM. Then the detailed information will be accessed from the library. So the first step will be just try to load the data sets. This is the training data. So training data, for instance, it say that df.pd.read_csv. So this is just, for instance, we have just a CSV data set that's stored in somewhere. So in order to read that data set, df, which is a data frame, so this is just a sample data file name. PD, which is a panda. Here you see PD, define panda site PD. That's why PD here. So pd.read_csv, all data.csv. So the CSV data is read like this one. Then when you say that df.head, df is here, .df head means like to display the information. So like the data set looks like this one. This is a sample data that only just display the top 5 one, but the remaining one is still just hidden. So the data looks like this one. So the first step is just like if you have already the data, if the data is ready, so you can upload the data by using pd.read_csv. So if the data is CSV file, you can use read CSV. If the data is text, you can just say that pd.read_text, or also you can just like load by using load the data sets. Then the second step will be a min-max normalization. What is min-max normalization means? Just the way of just like the first step, separating the training data and the target data. I mean the input features and the target. For instance, X is that's just like the input features and Y is the target. So from this one, for instance, from the data set, you see that P1, P2, P3, and then until P2001, and FFG1 and FFG2, this one, the two will be the target or the class. So our target is like try to predict the peak wavelengths of these two FFGs. That means from the whole data, the last two columns will be the target that is just ready for as a class. The rest one will be that used as and training input features. So that is why X means the whole data except the last two columns, and Y or target means only the last two columns. So X store information for the whole data except the last two columns. Y is only included, so there is a difference. Actually, this is ilog by using ilog, or there are different way of actually we can use also drop to split like or to separate the input features and the targets also, but you can use different ways. So this X and Y value, the conversion into the NumPy arrays like this one. So X and Y is X dot values and Y dot values. So this value will be, or this one just change it into, this data will be changed into the arrays here. And then we can just scale values for modules. So by using minimax scaler, this one actually for data normalization. So data will be changed into 0 and 1. So Y scale also is changed into 0 and 1, like this one. So X and Y will be just from this scale will be fit transformed by into 0 and 1. This is called, we call it data normalization. Then the next step will be just we try to split data into training and validation set or test set. So X train, X test, Y train, Y test. This is just X train is for training and X test and Y test is for testing. Train test split. This is just actually a keyword. X, Y. X is this one, Y is this one, which is like the input feature and the targets. And the size of splitting the data is 0.20 means test data should be 20%. If you need 30%, you can make it this one 0.30. So let's see, for instance, after splitting this one, X train is like around this one. X test is 155, so 624 is for training, 156 is for testing. And this one is 2 means actually because the target or the class is 2, that is why this one is become 2. because in the data you see that the last column will be the class. So y-test, this one is like helps to y-test and y-train actually that try to like, for instance, the last one, it will be just try to help to store the class. Then we can try to develop, for instance, this is LSTM model. So in order to develop LSTM model, we can define LSTM as a feature. This is with function, but you can define also without function. And let's say the model name is FPGA sensor LSTM, or you can give any names. Model is equal to a sequential, because this one is that helps us to create a sequential LSTM models, because it's like a type of sequential model. And then we can add the first LSTM layers and some dropout regularization for overfitting. So we can say that model.add, because here the model is just started or created model. Model.add LSTM unit is equal to 824, means this one is the number of neurons. So this is just the first layer. Return request is equal to true, means like then the output will be displayed at each step. And this is the input shape will be just like the futures, because here we just like we can say that if so this is just and then we can add dropout here. Dropout model.add dropout 0.2 means actually 20% of the layers will be, or the neurons will be dropped. And adding a second LSTM layer, so this is the first layer, then we can add also the second LSTM layer. Model.add like this one, unit is equal to 256. So in this one the neuron is 824, but in this case we can make it 256. Maybe this one is not accurate, so you need to just like try and error by changing the layer. So these numbers will be just arranged by, you can change these numbers in order to until you find like the best values. Reserve skills, maybe no need of just return every step. Activation function, then just give like some activation function, tanh, relo, any activation function you can try. Also add dropout in the second layers, and adding third layer here, add dense, and this is just like the last one should be the output layer. The output layer is just only equal to the class or target. So we already say that our class is 2, 1, FPGA1, FPGA2 for 2 sensor. So that is why here the output layer is 2, because of we have only 2 class. So the activation function is softmax. Here is activation function tanh. So actually just this one try. So you can also try by using relo activation function. This one, for instance, here, so in order to calculate the timer, for instance, at the beginning, I already defined here from timer time it import default timer as a timer. So in order to calculate the training time, here already defined. So here start time dot time. So just like calling this one. So and then start at the end of the code. I mean in this model specification, start is equal to timer. It just like calculates this training time. The total training time will be calculated just like doing this. So this is the structure. It looks like this one. So already the module is defined or compilation in here. Then module LSTM xtrain.shape, actually just this one is reshaping. And the summary of the model looks like this one is assigned like this: first layer, dropout, second layer, and the last layer, just like this structure actually, which is like this is like from the different modes. Then training here, model LSTM.fit, then xtrain, ytrain. Then this one is batch size epoch will be defined like this one. Actually, this is a screenshot from that one. GRU, the same. The only difference actually here is GRU, and the other one is just like the internal structure is the same. So we just like there is model sequential, model added, then here is GRU, dropout, then dense layer, then timer. The other structure will be the same, and this is just the structure that shows that how the GRU model looks like, that one. And then after training the models, just we can make it a prediction for testing data. So pred y is equal to model.predict, for instance, a prediction y or y test or like that one. So we can try to predict the new test data. And finally, we can perform evaluation. So in order to perform evaluation, we can try to compare the output of the model and the actual data. So actual data means the data that's already stored in the expected classes or targets. So In this case, actually, this one we call it the actual data. So the model also expected to predict the FPGA and FPGA's peak wavelengths when we give a new test data. So by comparing this one, we can just try to evaluate this one. So mean square error is Y pred and pred Y. So Y pred actually, pred Y is this one, the prediction one, and Y pred is just like the actual one. So by comparing this one, we can, because this is a prediction or a regression, the data is like a continuous data. So the performance metrics should be mean square error, mean absolute error, and root mean square error. So for regression type of data, which means if the data is continuous and if we use like prediction instead of classification, the performance measure will be either mean square error, mean absolute error, root mean square error, R square error, R square, yeah, or accuracy will be some of the parameter. But if you do like for classification, you can use accuracy, precision, recall, F1 square, and like confusion matrix will be like that one. So because of this one, the problem is for regression. So I use like different performance metrics like this one. So just this is how just implement GRU and LSTM for in real world applications. Actually, this is just like the I already implemented this one in earlier applications already. The this one is the paper is already also published in IEEE sensors. That's just how just using LSTM and GRU for vivid sensor wavelength predictions. So within different conditions, especially for instance, if the sensor data will be just vary due to strength, due to temperature, due to accelerations, it will be very difficult to analyze manually. So to solve that problems, just using deep learning techniques like GRU, LSTM, or maybe also the other algorithms to solve or to analyze sensor data will be the one solution. So that is why here also I use GRU and LSTM for predicting sensor data. So the other application maybe like GRU and LSTM will be important for time series applications. This is just for sentiment classification, for image captioning, for traffic counting, for text generation language modeling. It's just like there are also for chatbot also recently actually ChatGPT will be important. So for instance, when you give like a text, how are you? And then the just like it will be try to answer, I am fine. So ChatGPT is that just also a model, a deep learning model. By using huge amount of training data, it try to understand the questions from like different users. That's also the one technique. In chatbot like this one. So you see that encoder input, decoder input, and then finally we can get the outputs. Okay, just like the last topic is for this video tutorial is about generative adversarial network. So I just will give you just short explanation about generative adversarial network or GANs. So the other model, deep learning model, is GAN or generative adversarial network. So this is a type of model that helps us to generate synthetic data or artificial data. That is just this is maybe due to different reasons, because due to time constraint, due to lack of human power, or due to just lack of different experimental devices, maybe we cannot get enough data for training the model. So during that time, we can just like collect some sample data only. And then by using this generative adversarial networks, you can just like collect huge amount of data. So this is a structure that shows that the generative adversarial network. So the schematic of generative adversarial network, which is consists of two neural networks. The generator, this one, plus a discriminator, this one. So GR you have, GAN have two different parts, generator and discriminator. The generator, the main function is used to produce the approximated samples from n-dimensional random noises or that generates data. So there is here a noise and try to generate data. And then the discriminator will be actually here, you see that there is real data also is given for the discriminator. That's just a sample data. So the generator and this discriminator will be generate a data or a simulated or synthetic data that's more similar with the real data sets. So the discriminator in this case will be used to identify whether a sample is real or fake. You see here? So this is real data and the generator is generate data. So the discriminator try to check that whether the data generated by the generator will be real or fake. So just calculate the loss function based on the feedback actually will be goes into the generator and try to still generate the data. So we can adjust different parameters. If in case the generated data is different from the real data, we can go in the generator and we can adjust some parameter. So these two networks compete with each other and then try to optimize gradually to realize data augmentation techniques. So this is also the structure. Like training in GAN model involves back and forth process where the generator aims to maximize the probability of the discriminator making a mistake. See, that's the computation. So which means that it tries to generate data so realistic that the discriminator classifies it as real. So the generator can try to generate more realistic data, which is similar with real data. And then he try to make it, the discriminator classifies that this is reals. While the discriminator try to just minimize the probability by getting better at distinguish real from the fake. So just try to, this is a training data. For instance, this is real samples. And this is just a generator, try to generate some data using also random noises. And then this is a generated fake sample, for instance. So this is a real sample, and this is generated fake sample. And then there is a discriminator here. A discriminator will be just like discrimination losses and generation losses will be calculated. And there is real and fake one is identified. Based on this performance, there will be back propagation that checks the errors. And still we can try to make it or optimize this one. So the training process just try to reach point of equilibrium where the generator produces a perfect replica of the accurate data. So as much as possible, the generator will be just try to synthesize or create a data which is more similar with the real data. So which means that already we can get a data set which is similar with the real data or the real experimental data, and that helps us to use like as a training data set is for our model. So using these techniques, actually we can try to generate more data using the GAN. So just this is a hint about generative artificial networks. Maybe you can just refer more about generative artificial networks. And also there are different algorithms about deep learning models like YOLO, deep belief network, and meta learning and transfer learning, and encoder, autoencoder is other part of deep learning models. Maybe we will see this one in the maybe in the other classes, but for today we will stop here. And this is just some of the sample reference about the recurrent neural networks and about the generative neural network. So this is all about the video tutorial about deep neural networks, and I hope you get some information about deep neural networks and then how you can deploy your deep learning models. So just you can try to see the videos and you can refer the other resources. And still, if you have any doubts, you can just contact me by using our email address. Thank you very much for your time.